the distance between a node and an antinode is a quarter wavelength. So we have 1, 2, 3 quarter wavelengths here. So the length of this air column is 3/4 wavelengths. That's easy, right? Now this is the displacement node, and it's here where here and here where you are going to have the maximum changes in pressure, rather than here and here. As the displacement antinodes, you actually have no variation in pressures. The reason is because displacement nodes are actually pressure antinodes, and displacement antinodes are actually pressure nodes. Let me just briefly explain why this is so. So let's look at the displacement node here. Notice that the air molecules on both sides of a displacement node are always displaced in opposite direction. So at this instant, you can see that the air molecules on the left and the right are displaced outward. So you have rarefaction here, right? Air molecules are displaced left and right, so outward. So you got rarefaction at the displacement node. Half a cycle later, notice that the air molecules on the left and the right are displaced inward. That's when you have a compression at the displacement node. So you can see that at the displacement node, the pressure actually changes from rarefaction to compression to rarefaction to compression. If you look at the displacement antinode, which is here, then you will notice that the air molecules on both sides of the displacement node are always displaced in the same direction. In fact, the molecules at the antinode itself are also displaced in the same direction. So I have my finger, this one, antinode. This one is on either sides of the antinode. So at this instant, they are all displaced to the left. Half a cycle later, they are all displaced to the right. So in fact, at the displacement antinode, they are just doing this. So the separation between them doesn't change, which means the pressure at the displacement antinode actually doesn't change at all. So displacement nodes are pressure antinodes, displacement antinodes are pressure nodes. Alright, that's it. Ta-ta!